Okay, I wanted to go over the formula for acceleration. So here on my little whiteboard at home, A is for acceleration. The formula is final velocity minus initial velocity over t. Okay, let's see if I can get this to stand up without crashing. Yay! Okay, so F stands for final velocity. I stands for your initial velocity divided by whatever time is mentioned in your formula. Okay, final velocity a lot of times can mean stopping. Okay, say you're going down a roller coaster and you stop. Okay, that's going to be your final velocity. Sometimes it can be 0 or it'll give you a number. It's always the final velocity. Final velocity always goes first. Okay. Next is initial velocity. Okay, this is your starting. Okay, if you start, you always start from 0. Or it'll give you an initial velocity, a number that you start at. Just look for start time or initial time, and you'll be able to tell if it's an actual number or if you use 0. Okay, and then remember the formula. Acceleration, okay, when you write the units, is a distance, which can be meters, miles, just any number distance, kilometers, divided by time, usually seconds, hours, or minutes. So you're going to get meters per second squared. Okay? All right, let's move on down to my paper. Okay, I worked out number 1 for you. Let's see if I can hold it up. Maybe that'll look a little bit better. Or not. Okay. Hopefully you can see this. All right, number 1. Okay, don't get distracted. Maybe I can zoom in. You can look at number 2 if you want. But anyways, a roller coaster. Car rapidly picks up speed as it rolls down a slope. As it starts down the slope, its speed is 4 meters per second. So my key word is start. So that's how I know starts down. That is my initial velocity. Initial. So that's why I put my 4 here. Okay. 3 seconds later, seconds is a unit of time. So I know that my 3 goes down at the bottom because that is time. At the bottom of the slope, its speed is 22 meters. Okay, so it's at the very bottom, so it's at the end, so it's final. So you do 22 minus 4, you get 18, and 3, okay, so 18 divided by 3, 6 meters per second squared. Make sure you always include the units. Excellent. Okay, next, a cyclist accelerates from 0 to 8. Okay, so well, he starts at 0. If I'm starting at 0, that is my initial. Okay, if he goes to 8, that's his final. So I put 8 here. So 8 minus 0 divided by 3 because that is my time. I divide that out, I get 2.7, or repeating 6, doesn't matter what you use, meters per second squared. Okay, number 3, a car approaches a stop sign going 5 meters per second before it comes to a stop. Okay, so if it's coming to a stop, that is its final number. Okay, so final is going to be 0. If it's approaching going 5 meters before it stops, that is its initial, so 0 minus 5. If it does this in 4 seconds, what was its acceleration? So I do 0 minus 5 divided by 4 equals 1.25 meters per second squared. Okay, let's go on down. Okay, this one was tricky. Okay, it really kind of was. But you got this, so I'm going to show you. A car advertisement claims that a certain car can accelerate from rest to 70 kilometers per hour in 7 seconds. So you had to do something really hard. You had to convert, 7 to hours. Okay, most of the time I would have gave that to you, but I wanted to see what you could do. Okay, so simply, I do the cross-out method. I'm not quite sure what you're done in math. But I know, okay, for seconds. So when I use my converting factor, there are 3,600, you can't read that, so I rewrote it. 3,600 seconds in 1 hour. Okay, so if I divide this so that I can cross out my seconds, okay, I do 7 divide by 3,600 to get 0.00194 hours. Okay, so if my car can accelerate from rest, rest is my initial, which is 0. Final is 70. So I do 70 minus 0, divide by my my hours. Okay, and I still didn't write it down correctly. It's not meters per second squared. It is kilometers per hour squared. Apologize for that. Okay, so when you do the math, you get 36,842.11 kilometers per hour squared. Okay, excellent.